Okay, so this is really just more multiplying polynomials, and it'll be for the most part multiplying binomials, but sometimes we can make it look a little different, right? So 2x plus 1, and then I can write squared. So let's say you want to simplify that. Well, you just have to remember what squared means. Squared just means you're multiplying this thing twice. So 2x plus 1 times 2x plus 1. So we're just multiplying two binomials that happen to be the same. So you use the distributive property. So the 2x into the second bracket, both terms, and the 1 into the second bracket, both terms. 2x times 2x, 4x squared, 2x times 1, plus 2x, 1 times 2x, plus 2x, and 1 times 1, plus 1. So simplify by adding like terms, those middle terms. So 4x squared plus 4x plus 1. So when I expand this, I get a trinomial. One comment about this one, and this is a mistake. I just want to show you a mistake that tons of people make. I'm going to do it in a different color, and then I'm going to cross it out because I don't ever want you doing this. So this is a big mistake people make. And I mean, it's sort of understandable. What they do is they say, okay, 2x plus 1 squared. I'm going to square both terms. So they say, okay, if I square the 2x, I get 4x squared. And if I square the 1, I get 1. But notice that's not what we should have. You're missing the middle term because you didn't do the squared properly. Squared means you multiply the bracket by itself. So don't ever do this. That being said, people will do this. I guarantee you when I give you a question like this on a quiz or a test, people are going to make this mistake. But I'm showing you this example so that hopefully you are not the person that makes a mistake. Okay, and then another, I guess we can consider this a special product, is if you have something like this, 2x minus 3 and 2x plus 3. So notice these are almost the same binomial, except the difference is the sign in the middle. So something sort of interesting happens when you do this. And it's going to become important later on, but you do it the same way. You multiply the first term by both terms in the second bracket, and the second term by both terms in the second bracket. So 2x times 2x, 4x squared, 2x times 3, 6x, minus 3 times minus 2, minus 6x, and minus 3 times plus 3 is minus 9. So notice now when we collect like terms, 6x and minus 6x, those become 0. Right? So they kind of cancel each other out, and you just have 4x squared minus 9. And this, when you have this situation where the first bracket and the second bracket are almost the same, just off by the sign in the middle, that's going to happen every time. The middle terms will be like terms, and they'll cancel out. One will be positive and one will be negative, and you'll be left with just two terms. And actually, one of them will be just the square of the first thing, and the second one will be the square of the second thing. Just let's actually do another example just so you see. Maybe illustrate what. Let's look at the other one at the same time. So example, let's go with 5x plus 1 and that's 5x plus 2 and 5x minus 2. So expand the first 5x into the second bracket, so 25x squared minus 10x, and then expand the 2 into the second bracket, so plus 10x minus 4. So notice the middle terms again are like but opposite signs, so they cancel. You have 25x squared minus 4. So again, two terms, and notice the first term is just the square of the first terms here, and the second term is the square, or is the product of 2 and minus 4, of 2 and minus 2. Okay, and again, it's the same thing that happened up here. So that will happen every time. So those are just a couple special products. Really, I mean, they're almost, they're not different than what we did before. They're just going to become important later on.